Hey YouTube, welcome back to my LeetCode series. In this video, we're going to solve question number 268, missing number, and it's an easy question. In this series, I solve LeetCode problems without seeing them before, so you are seeing the problem as I'm seeing it in real time, and the purpose of this series is for you guys and girls to get a perspective of my thought process, how I come up with a brute force / naive solution and bring that to an optimized solution. So you can kind of see the game sense and kind of patterns and tricks that I apply. And the purpose of the series is for you to learn how to problem solve and critically think. Because at some point, memorizing LeetCode problems does not scale. And if you get a question in an interview that you've never seen before, you'll need to be able to problem solve. You can't just be a potato, as another person that another YouTuber describes it. You can't be a potato and just not try to solve the problem. You have to figure out how to solve it. So with that being said, if these videos help you, please make sure to like and subscribe for more content like this. So yeah, let's hop into the question. We're given an array containing n distinct numbers, and we know the range of the numbers is between 0 and n. Find the one that is missing from the array. Okay, so the first thing we can do clearly is the brute force solution would be to set I is equal to 0, and then we have like a while true. And what we do is if the array, if nums contains I, then continue. Otherwise, we return I. But the thing is, this brute force solution, the time complexity is going to be O of n squared, and the space is going to be constant. And the reason why it's O of n squared is because I loops from 0 to n possibly, and then we check to see if the array contains a specific number, and we have to search the entire array. So that's the brute force solution. So these numbers, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, eventually this if statement will be false, and then we'll return I. So an optimized solution would probably bring this time down to O of n, and the trick with double for loops is to usually use some sort of hash map. So if we use a hash map and we loop through nums and add not even a hash map but a set, loop through nums and then add nums.I to set. We have a set here, so we have some sort of lookup table, and then we loop through I from 0 to n, and if I is not in set, return I. And we can throw an error here because we're guaranteed to have a solution, I'm pretty sure, and there will definitely be some I between 0 and n that's not in the set. But that uses space, so the final probably the best solution, I'm guessing, is still linear time complexity. It doesn't really make sense to use binary search because we can't sort it. And the space would probably be O of 1. Your algorithm should run in linear runtime complexity. Can you implement it using only extra space? So usually with these questions, if you want to use extra space, we usually have to reuse the input array itself, and we have to have that the range of nums is between 0 and n. So this is usually using the cyclic sort technique, which maps the numbers to the correct locations in the array. So for the first example, if we have 3, 0, 1, what if we the values map to a specific index except 3. So 0 and 1. So 0, we can flip the element at the 0th index to negative. And then for 1, we flip the element at the first index to be negative. Then we see that we then loop through nums, and the first value that is positive, we return its index, because that means we have not seen a number that is mapped to that value. For example 2, we have 9, 6, 4, 2, 3, 5, 2, 3, 5, 7, 0, 1. What we do is, okay, let's just start counting. 0 is going to be negative. We have a 1. We see a 2. 0, 1, 2. We see a 3. We do not see a 4, so 5 is not negative. We see a 5. So 0, 1, 2, 3, 4, 5. We see a 6. So 0, that's the problem. We can't set 0 to negative 0. But I don't think that's the best solution. So that's 0, 1, 2, 3, 4, 5, 6. And we also see a 7. So the number that's missing is 8, and that's because all the numbers are negative. So if all the numbers are negative, so this is 0, 1, 2, 3, 4, 5, 6, 7, then we would return the length plus 1. But what if we saw 8 and we didn't see 9? There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers, and there's 9. So am I tripping? 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 9, 6, 4, 2. Oh, I'm missing a 3 right here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. So because all the numbers are indeed negative, then we return the length plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or the length minus 1. So we return the length minus 1, so that would be 8 in this case. What if we have the exact same case, except we're missing 9 and not 8? Because I'm just curious as to what the 9th element is supposed to map to. Because then all of these should be negative. Zero, 1, 2, 3, 4, 5, 6, 7. But this is not negative. Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8. This is negative because we have minus 8. 0, 1, 2, 3, 4, 5, 6. Right, so in this case, I just got tripped up. This last case wouldn't be negative because we don't see an 8, and then we return we just return A here. Here we return the length of 9. So I'm going to code this up. It's a pretty simple thing. I'm just going to kind of skip the pseudocode. What's going to happen is we're going to loop through all numbers. And then nums at n do if n is less than, if the absolute value of n is less than const index is equal to the math absolute value of n. And if the index value is not n itself, or like the length of n, because it's potentially the length of n, Then we'll set nums at index equal to negative nums at index. So if the index is in bounds and nums at index is positive, then we'll loop through nums itself, and we'll check if nums at I is negative, then we'll return I, or if it's positive, we'll return I, because that means we've never seen a value that's mapped to it. If the loop exits, then we return the length itself, because that means all 0 to n minus 1 values were negative. Let's submit this. So our output is 2, when this should be returning 1. Right, so if it's 0, this is kind of the stupid part of this question, I believe. I mean, technically, we don't even need to set null, because we don't need 0 to be unique, so we can just set it to -1. It's still a negative number nonetheless, right? But then we'll probably fail if we need to map 0 to a later index. Right. Okay, that works. I had to do a null thing. It seems to be there's a bit manipulation as well, but we're not going to do with that. We're not going to do that solution. We're just going to stick with cyclic sort, and we'll go over the bit manipulation questions later. So that was my thought process for this question, 268, missing number. If this has helped you in any way, please make sure to drop a like and subscribe for more content coming up. See you in the next video.